In this chapter, we shall discuss about how to make approximations using derivatives. The approximation using derivative is done by, first we take the definition of derivative. If you remember, definition of derivative is using limit. We know f of a plus h minus f of a upon h when limit h tends to 0 is known as f dash of a. That is, initial value of the y coordinate is f of a. The new value of y coordinate is f of a plus h. So this gives the difference. Numerator gives the difference in the y coordinate when x changes from a to a plus h. When x is changing from a to a plus h, the y coordinate changes from f of a to f of a plus h. So this is the new value. This is the old value. New minus old gives you the change. So the numerator is change in y coordinate. Denominator is change in x coordinate. So this is a ratio of change. And ratio of change is known as derivative when the change in x tends to 0. That is the basic definition of derivative. Now from here we derive the dy by dx, etc. All the derivative formulas are derived from this definition. So how will we apply this for calculating the approximation? What I'm going to do is, I'm going to remove this limit. You know that when h is very small, when you say very small, we are comparing with the a's value. Initial value of x is a. The initial value of x and a, if you h and a, if you compare, h should be comparatively very small. Then only this formula works. When h is very small, f of a plus h minus f of a upon h is approximately equal to f dash of a. That is, limit h tending to 0 has been removed. Why it has been removed? Because this formula, they both are almost equal when h is very small. That's what the theorem says. That's the definition says. So from here, f of a plus h, I'm making f of a plus h a subject, minus f of a is approximately equal to h into f dash of a. So finally, f of a plus h is approximately equal to f of a plus h into f dash of a. This is the definition that we are going to apply for calculating the approximation. So a function's value, this is a y coordinate. The new value of the y coordinate is the old value of y coordinate plus increase in x coordinate multiplied with the derivative's value. First, let me explain to you how do we apply the formula that we have just learned before on to calculate the approximate value of 2.01 the whole cube. You must notice here that there is a number involved in it and there is an operation involved in it. The number is 2.01, the operation is cube. So we will define first what is a function. So step number 1 and define the function f of x. F of x, the number if you replace by x, replace the number by x. So I can write here f of x is, number is what? 2.01 x cube. Don't get confused between this cube and 2.01. The number is always something with a decimal because we are calculating approximation of something. So if it was only 2 cube, we know 8. So we don't have anything to approximate. So there will be some decimal part involved whenever we want to find the approximation. That number with that decimal part is your x. So if you replace that number with the number with x, you will get the function. Suppose I want to calculate tan inverse of 1.001. Here the number is 1.001. So the function is tan inverse x. So if you replace the number by x, you will get the function x. Then what you do is calculate its derivative. So this is the first step that you must do. Define the function. Replace the number by x, you will get the function. After that, find its derivative and keep it ready. Then you will calculate, then you will write the formula. Formula to calculate the approximation. We have learned the formula is f of a plus h is approximately equal to, when the x coordinate becomes a plus h, the new value of the function is original value of the function f of a. Naturally, the new value is original plus something more. What is something more? Whatever increase in the x coordinate is increased to by h. So h into the derivative's value. So if I want to calculate f of 2.01, remember this a plus h became your number. So a plus h is your number. So I told you, you obtain the function x by replacing the number by x. So what is the number in the formula? A plus h is the number. So you can see a plus h is 2.01. Now we can divide. A is 2 and h is 0.01. This you have to be very careful while dividing. When you are dividing a and h, what part of this is a and what part of it is h? A should be, if you replace x over here by the number a, it should be mentally calculatable. For example, f of 2. F of 2 is 2 cube, 8. We could easily calculate. Suppose I would split it like this. A has 2.005 and h has 0.005. Even if you add this both, I can get 2.01. But then what happens in f of a, when I try to calculate f of 2.005, it will become very difficult for me to calculate. Hence, I cannot split in this manner. F of 2 plus 0.01 is approximately equal to f of 2, a is replaced by 2, a plus h is 2.01, a is replaced by 2, plus h 0.01 into f dash of 2. So you need to learn how to write this. F of 2.01, so first number is 2, so f of 2, plus whatever the increase in the decimal, 0.01, the change in the x coordinate, into derivative of 2, derivative of the function at 2. So f of 2 plus 0.01 into f dash of 2. Now f of 2, how to calculate f of 2? Replace x by 2 here. So that is 2 cube plus 0.01. F dash of 2. F dash of 2 is derivative's value. 3 into 2 square. So f of 2.01 is approximately equal to, you can either use this notation or you can use this notation. Anything will do. So now we'll calculate this value. This value will be equal to 8 plus 0.01 into 4 into 3, 12. That becomes 8.12 becomes your answer. Therefore, the approximate value of 2.001, approximate value of 2.01 the whole cube is 8.12. That becomes your answer. Let's just discuss how we define the function. I want to calculate square root of 24.9. You know that square root of 24.9 is near to square root of 25. Square root of 25 we know. So first of all, what is the function f of x here? Replace the number by x. What is the number here? 24.9. Replace it by x. That will be f of x. What will be the f of x in this case? Replace 26.99 by x. So the cube root of x. What will be the function here? Replace 32.02 by x. So fifth root of x. So the function is defined by replacing the number by x. Then of course you can calculate the derivative. Now let me come to how will we take a plus h. 24.9 square root is near square root of 25. So 24.9 should not be written as 24 plus 0.9. It should be written as 25 minus 0.1. Because the square root of the operation f of x should be applicable for the number that you write first. Initial value of x coordinate is 25. Is decreased by 0.1. Instead of increase, here is decrease. So your function f of a plus h is approximately equal to f of a plus h into f dash of a. Let's see how this will happen here. So 24.9, f of 24.9 is f of 25 minus 0.1. Now your a is 25, h is minus 0.1. So your definition will become f of 25 minus 0.1 into f dash of 25. F of 25, root of 25. So this will become 5. F dash of 25, f dash of 25, f dash of x is 1 by 2 root x. So if you replace x by 5 here, it will become 1 by 10. So you can calculate f dash of 1 by 2. So this becomes root of 25 minus 0.1 into 1 by 2 root 25. So now you can easily calculate it is 5 minus 0.1 into 1 by 10. So this is 5 minus 0.01, which is 4.99. So the square root of 24.99 is 4.99. Now let's have a look at the same over here. How do we complete here? Here 26.99 is cube root. So a number whose cube root is known to you is 27. So your function f of a plus h is approximately equal to f of a plus h into f dash of a. So here 26.9 is 27 minus 0.01. Why did you select 27? Because cube root of 27 you know. Why are you not taking 26 plus 0.99? Because square root of cube root of 26 is not easy to calculate. So f of 27 minus 0.01 will be f of 27 minus 0.01 into f dash of 27. So when h is reducing, naturally from the original function, this is 26.999. This cube root of 26.9 is less than the cube root of 27. That's why the minus will come here. If it was 27.01, it will be more than 27, cube root of 27, then this would be h would be plus. So now you can calculate and put the values of this. Now let's have a look at this one. Fifth root of 32.02. Fifth root of 32.02 is near fifth root of 32, which is 2. We can mentally calculate. So here our formula would be f of 32.02 is approximately, your a is 32. So f of 32 plus 0.02 into f dash of 32. Let's find the approximate value of cube root of 7.99. 7.99 is near the cube root of 8. It is near cube root of 8. So naturally, the answer of this will be little less than 2. 1.9 something is going to be the answer. Okay, that you have to keep it in mind. So what I'm going to start with is, the first step is define the function. How do you define the function? Replace the number by x. Replace the number by x. It's cube root of x. I'm writing as x raised to 1 by 3. As soon as you find the function, next step is to find its derivative. 1 by 3 x raised to minus 2 by 3. So once the derivative is done, then we go for the formula. What is our formula? F of a plus h approximately equal to the original value of the y-coordinate f of a plus something more. What is something more? H into its derivatives value. Original value plus something more will give me the new value of the function. Now what is a plus h? The number is a plus h. How should I write the number as? 8 minus something. So I can write 7.99 is equal to f of 8 minus 0.01. Why did I select 8? Because cube root of 8 can be easily calculated. Why I did not write f of 7? Because cube root of 7 I cannot calculate easily. So this is equal to f of 8 minus, what was the number here? 0.01 into this derivative f dash of 8. So very easy to write. F of 8, this number, f of 8, then this number, then derivatives value. Very easy. You have to look at this only and write. Don't have to mug up this formula. F of 8 minus this number, no f of for this number, into derivative f dash of 8. Then f of 8 value, 8 raised to 1 by 3. F of 7.99, okay, is equal to minus 0.01 into 1 by 3 into 8 raised to minus 2 by 3. Now what you do is, to calculate this value, this looks a little complicated. 8 you substitute as 2 cube, so your value calculation will become very easy. So cube root of f of 7.99 means what? F of 7.99 means cube root of 7.99 is approximately equal to 2 cube raised to 1 by 3 minus 0.01 into 1 by 3 into, Now 2q raised to minus 2 by 3, which will give me 2 minus 0.01 into this, and this will get cancelled. So 2 raised to minus 2. 2 raised to minus 2 is 1 by 4. That becomes 1 by 12. So 2.01 into 1 by 12. Now this, if you want, you can make a little more approximation. 2.01 into 1 by 12. 1 by 12 is 0.0. 100, how many times 12 goes? 12 goes 7, 8. 896, 40. 40 means 3. So I can write this way. So my final answer became 2 minus 0.2 decimal 00083. That became 1.999, and this becomes 17. So if you approximate it to 4 decimal, so I can say cube root of 7.99 is approximately 1.992 if you approximate to the 4 digits after the decimal. We need to find the value of sine 31 degrees. Before I start the sine 31 degrees, I want to ask you one question. When I apply the formula, derivative of sine x is cos x. X should be expressed only in radians. So 31 degrees, we cannot do any calculus with the degrees. So the value 31 degree should be converted to radians. That's why they are given us 1 degree is so many radians. So whenever we apply any calculus application in trigonometry, we got to have the number only in radian, and we should never take it in degree. So it will not be applicable in degree. If I say sine x degrees derivative, it is not cos x degree. You have to convert into radians, and then only you can take the derivative. So what I first and foremost thing, what is define the function. The function f of x is sine x, but remember x is in radians. Then only I can apply the derivative of sine x as cos x. So the first and foremost thing you must remember, the defining of the function is replace a number by x. So 31 degree is replaced by x, but it's not 31 degree, it is x radians. Then only derivative of sine x became cos x. Now we'll apply the formula. That is, step 1 is over, step number 2. F of a plus h is approximately equal to f of a plus h into f dash of a. So this formula is applicable only when h is very small compared to a. You must remember that. Now I need 31 degrees to be converted into radians. So 31 degree is 30 degree plus 1 degree. 30 I can write as pi by 6. So I converted directly to radian. And 1 degree I have been given in the question, 0.0174. So now I can write f of, instead of 31 degree, I'll write this. F of pi by 6 plus 0.0174 is approximately equal to f of a, the special angle, f of pi by 6. Always you need to have the special angle, otherwise you cannot find the value of f of pi by 6. So 31 degrees is near 30 degree. 30 degree is converted to radian, s of f of, so that's how you got pi by 6. So f of pi by 6 plus 0.0174 into f dash of pi by 6. Now we will put the corresponding value. F of pi by 6, replace x by pi by 6 here, sine pi by 6, plus 0.0174 into f dash of pi by 6, cos pi by 6. Now sine pi by 6 is half, so 0.5 plus 0.0174 into cos pi by 6 is root 3 by 2. Now we will put the value of root 3 by 2 is nothing but 0.866. So this is 0.5 plus 0.0174 multiplied by 0.866. Usually they give you in the question cos 30 degrees is 0.866. Otherwise, divide the value of root 3 by 2, you will get 0.866. Now you need to multiply this and write the approximate value. The approximate value will be 0.5. So this calculation approximately is 0.01508. That gives you 0.51508. So I can say your sine 31 degrees is approximately 0.5151. This is my approximate answer. Now we'll calculate cos 89 degrees 30 minutes. Here 1 degree is given as 0.0175. So sometime in the question they give you 74, sometimes they give you 75. That is according to the question what is given, we go by that. So first of all define the function. What is the function here? Replace a number by x. So the function f of x is cos x. Function f of x is cos x. Its derivative f dash of x is minus sin x. Now the number should be converted to radians. So I'll take here a plus h is 89 degrees 30 minutes, which is 90 degrees. You know that 60 minutes makes 1 degree. So you need 30 minutes more to make it 90 degrees. So minus 30 minutes. So 89 degree plus 30 minutes plus 30 minutes will make it 90 degrees. So because 60 minutes makes 1 degree, that's why 90 degrees minus 30 minutes. 90 degrees is pi by 2. 30 minutes is converted to degree first. So 30 by 60, now it is converted degree, then multiplied with 0.0175. So I can write pi by 2 minus 0.0175 divided by 2. We will keep it like that only. The calculation will do it last. Now I am writing the formula. F of a plus h is approximately equal to f of a plus h into f dash of a. F of, now we will not write 89 degrees 30 minutes, we will write this radians. Pi by 2 minus 0.0175 by 2. We need to express number in radians because derivative of cos x is minus sin x only if x is in radians. So if you want to apply this formula, x got to be in radian. So x got to be radian, but the given x in degrees and minutes. So converted to radians, and now we have to apply. That is approximately equal to f of pi by 2 plus, here h is minus. So minus 0.0175 by 2 into f dash of pi by 2. F of pi by 2, f of pi by 2, cos pi by 2, minus 0.0175 divided by 2 into minus sin pi by 2. That became cos 90 is 0, cos pi by 2 is 0, minus 0.0175 by 2 into minus 1. So my answer became 0.0175 divided by 2. That is equal to 0.0008, 16, 15, so 775. So that becomes my answer. So cos of 89 degrees 30 minutes is 0.00 approximately equal to 875. The approximate value of tan 45 degrees 10 minutes. The function f of x is tan x. F dash of x, its derivative is x square x. Now a plus h, here is the number 45 degrees 10 minutes, that is 45 degrees plus 10 by 60 degrees, that is pi by 4 plus 1 by 6 into 0.0175, because 1 degree is given as 0.0175 radians. So I can write now this as pi by 4 plus 0.0175 divided by 6. So this is A, this is H. So we'll write the formula. F of A plus H is approximately equal to F of A plus H into F dash of A. So F of pi by 4 plus 0.0175 upon 6 is approximately equal to f of a, f of pi by 4 plus h 0.0175 divided by 6 f dash of pi by 4. F of pi by 4 tan pi by 4 plus 0.0175 divided by 6 into f dash of pi by 4 6 square pi by 4. That became 1 plus 0.0175 upon 6 into this became root 2 square, that became 2, which is equal to 1 plus 0.0175 divided by 3, that is 1 plus 0.005 15 25, so 8 24 10 3. So my final answer is 1.00583. So I can write the value of tan 45 degrees 10 minutes is approximately 1.00583. This way we can calculate its value. This is my final answer. Let's take inverse trigonometry function. Find the approximate value of tan inverse 1.001. This is a tan inverse function. So the function f of x is tan inverse x. Here the number is 1.001. Remember, this is a real number. There are no degree, no radian. Tan inverse is a domain of this function is real numbers. So this x has to be x only. So f dash of x is 1 upon 1 plus x square, derivative tan inverse x. Now f of a plus h is approximately equal to f of a plus h into f dash of a. So your number is 1.001. So f of 1.001 is approximately equal to, we will take f of 1, tan inverse of 1 can be easily calculated. So f of 1 plus 0.001 into f dash of 1. That became f of 1 is tan inverse of 1 plus 0.001 into f dash of 1 is 1 upon 1 plus x square, so 1 plus 1 square. So I can say tan inverse of 1.001 is approximately equal to tan inverse of 1 pi by 4 plus 0.001 divided by 2, which is equal to pi by 4 plus 0.005. So we can leave your answer over here. So many radians. Further, pi is 3.1416 divided by 4 will give you 0.7854. Then add 0.005 to it, and this is your final answer. So since the textbook is giving you the decimal value, you also convert it into decimal value and write the answer in the decimal form. We'll find the approximate value of e raised to 1.005. The number here is 1.005. So the function f of x will be e raised to x, whose derivative f dash x also will be e raised to x. Now we need to calculate f formula. We need to write the formula. F of a plus h is approximately equal to f of a plus h into f dash of a. Replace a plus h by number. So f of 1.005 is approximately equal to f of 1 plus 0.005 into f dash of 1. Now f of 1 is e raised to 1 plus 0.005 into e, which is e is 2.7183 plus 0.005 into 2.7183. That is 2.7183 plus, now let's multiply 8 into 5, 41, 4, 9, then 35, 3, 10, 13, 0.0135,915. That will give me 2.7183, 0.0135,915. So 519,811,3,7. So my final answer is, so e raised to 1.005 is approximately equal to 2.7318 of 1016 to the base 10. Here the number is 1016. Function is log x to the base 10. So f of x is log x to the base 10. So f dash of x will be 1 by log 10 to the base e into derivative of log x. So that became 1 by x log 10 to the base e. This will be the value, and which can be written as 1 by x log e to the base 10, because I have given log e to the base 10 here. So 1 by log 10, base change rule I have applied. So when you interchange the base and the number, it will go to the numerator. Now we can apply the function formula. F of a plus h is approximately equal to f of a plus h into f dash of a. So I can write f of 1016. You know that log of 10's power can be easily calculated. Log 10 log 10 to the base 10 is 1. Log 100 to the base 10 is 2. Log 1000 to the base 10 is 3. So log 1000 can be easily calculated. So 1016 will be splitted as f of 1000 plus 16 into f dash of 1000. Now f of 1000 is log 1000 to the base 10. F of 1000 is log 1000 to the base 10 plus 16 into f dash of 1000 is derivative of f dash of x is 1 by x into log e. So 1 by x, 1 by 1000 into log e to the base 10. This I can write as log 10 cubed to the base 10 plus 16 upon 100 into log e. Log e is 0.4343. That became 3 log 10 to the base 10 plus 16 into 0.4343 will multiply and divide by 1000, which is 3 plus 0.069,488. That is 3.00695. So that will be my answer, 3.00695. Now let's find the approximate value of log 99 given log 10 to the base c. Now here is base c. So your function f of x is log x to the base e. So the derivative is directly 1 by x. And we want to calculate using this formula. So 99 log 10 is given to me. That means log 100 can be calculated. So f of 99, I can write it as f of 100 minus 1, which is f of 100 minus 1 into f dash of 100. F of 100 is log 100 to the base e minus 1 into f dash of 100 is 1 by 100. F dash of x is 1 by x. F dash of 100 will be 1 upon 100, which is 2 log 10 minus 0.01. That is 2 into log 10 is 2.3026. Remember, log to the base e, it is minus 0.01, which is equal to, so 52064 minus 0.01. So it is 4.6052 minus 0.01. So 52954. So your approximate value is 4.5952. So I can say log of, for my final answer, log 99 to the base e is approximately 4.5952 is my final answer. They have given us the function and we need to find the value of the function at 0.99. That means, which means I need to calculate f of 0.99. So a function is already given to you in the question. So I will find the derivative of the function 3x square plus 10x minus 7. Now I'll put the formula f of a plus h is approximately equal to f of a plus h into f dash of a. Now 0.99 is near 1. 1 minus 0.01 is 0.99. So f of 0.99, I will write it as f of 1 minus 0.01 because f of 1 is easy to calculate, which is approximately equal to f of 1 minus 0.01 into f dash of 1. F of 1, replace x as 1 here. So 1 cube plus 5 into 1 square minus 7 into 1 plus 10 minus 0.01 into f dash of 1, substitute over here, 3 into 1 square plus 10 minus 7, which will give me answer 1 plus 5, 6, 6, 16, 16 minus 7 will give you 9 minus 0.01. This gives you 3, 13, 13 minus 10, that gives you 6. So that is 9 minus 0.06. That gives you 8.94. So the approximate value of the function is 8.94. So f of 0.99 is approximately equal to 8.94.